free response no calculator section. So it says this region is bounded by y equals square root of x and y equals 1/2 x. Perfect. Now, part A. Part A says find the area of this region. So it's upper minus lower. So area, but it's free response question and you have to be specific. Show your work. Area equals. You have to say area equals. Not R equals. Area. Integral. So obviously it's from 0 to 4. That's all given. Upper would be the square root of x, and lower would be 1/2 x. And I think a lot of students did the same thing. But what you did wrong is either you integrated it wrong, or when you plugged in, you made a mistake, which is frustrating to me. So the square root of x you can express as x to the power of 1/2. So when you integrate, you get x to the power of 1/2 plus 1 over 1/2 plus 1 minus. And integral of 1/2 x is 1/2 x squared over 2. So we get 1/2 plus 1 is 3/2. So the reciprocal gives you 2/3. X to the power of 3/2 plus x squared over 4, 0 to 4. Plug in the 4, so you get 2/3. Now put it in radical form because it's hard otherwise. So the index, see this little denominator? That's your index. And the numerator shows you what your exponent outside is. Plus, plug in 4, so it's 4 squared over 4. And if you plug in 0, you get 0 for each. Now we get 2/3. Square root of 4 is 2, and 2 cubed gives you 8. And this part, 16 divided by 4 is 4. So what do we get? 16 over 3 plus 4 over 1. And what is it? 16 plus 12. So it's 28 over 3. You know what? Actually, I just realized I made a mistake. I don't know why I put a plus sign here. It's supposed to be minus sign. Minus. That's not good. So it's minus. And minus here. So it's 16 over 3 minus 4 over 1, which is, what is it? 4 over 3. 4 over 3 and no units. Next, part B. It says find the volume of the solid generated when R is revolved around the y-axis. Okay, so very important. So when you read, you need to underline each expression, each important statement. So I underlined, when I read this question, I underlined revolved around the y-axis. So if it's revolved around the y-axis, then you have to solve each equation in terms of y, not x. Your integral has to be in terms of dy, not dx. So the original equations are these. So we need to solve each one for y, for x, I'm sorry. So square both sides. So you get x equals y squared. That's the first one. And this one multiplied by 2, x equals 2y. That's it. Now, we're going to use the y boundaries, not x boundaries. And this point that's all given, 4, 2, so the y boundary would be, boundaries would be 0 to 2. So volume. In order to find a volume when your object is revolving, so you do pi. I hope you remember. It's kind of important to start with pi. From 0 to 2. Now, start at your axis of symmetry, and you're revolving around this line. So go all the way towards your graph, whatever is far away from the x-axis, y-axis. And then the other one is the shorter one. So you do outer squared minus inner squared. Why squared? Because we're talking about area of each disk. So it's pi, area of a circle is pi r squared, r squared. So that's why. So what's this outer? What function are we using? The line function. It's this one. So it's 2y squared minus And inner, the short one would be this one, the y squared, but again squared. And it says we need to solve. So it's pi integral 4y squared minus y to the fourth. And when you integrate, you get 4y cubed over 3 minus y to the fifth over 5, and the boundary is 0 to 2. So pi, that would be 4 thirds, and 2 cubed, you plug in 2 for y, so it's 8, minus 2 to the fifth, 32 over 5. And when you plug in 0, you get 0, so we're not going to do that. So we get, what is it, 24 over 3 minus 32 over 5. We need to find a common denominator. And again, I found that this mistake, that's why I paused here. So here's what my mistake is. 4 times 8. I hope you catched it right away. 4 times 8 is not 24, it's 32. So 32 over 3 minus 32 over 5. Common denominator is the 15, so you get, what is it, 160 over 15, 96 over 15, and your final answer is pi 64 over 15. So sorry about that. Next, that would be C. Part C says, write but don't evaluate the integral expression that gives the volume of the solid generated when R is revolved around the horizontal line y equals -3. So y equals -3, let's say it's somewhere here, -3, so we're rotating about this line. Okay, now you always start at the axis of symmetry and you go all the way up. That's your outer radius, all the way up. That's your inner radius, the short one. And the formula is volume equals pi, of course, we're rotating, integral x boundaries from 0 to 4. And now, if you remember, you do an outer, so this graph would be square root of x, minus axis of symmetry, minus negative, what's the axis of symmetry? Y equals -3. So it's minus -3 squared. Minus, and again, the inner radius, that's the graph of 1/2, it's 1/2, no, actually it's, is it -1/2 x? No, positive 1/2 x. Minus, and again, axis of symmetry squared. So the final, you can leave it like this, they would accept that, or you can just say square root of x plus 3 squared minus 1/2 x plus 3 squared, and we're good.